Okay, welcome. And you see the screen, yes. So the thing that I was normally teaching before midterm and now I'm teaching after is this term called factors. It's a thing that you don't find in other system, in other computer language. It's something kind of very particular from the statistical point of view, for the statistical software. So let's see what this thing that people call factors. So I want to present in this point of view. We are still working with the same data that we collected, but this is the clean data. By the way, someone asked me to send the clean code, and I have to send it yet. But anyway, the point is that we have this code. I think everybody got this one. If no, maybe we can put it in the website. Well, I think last time I sent it by the chat, but you have this data, no? You have this students 2018, 2020, tidy. Tidy is the one that where we corrected the city, the birthplace. Okay? Everybody agree? Move your head. Okay, good. Heads are moving. So, and these are the 10 columns. Okay, this is the column 10 variables. So everybody, I'm using, you strictly need this reader. I'm also loading this dplyr library just because there may be some we don't use it very much today, but it's good to have it anyway. It's a tool that we are learning this time. So as you remember, the basic point that we have with this data is that the birthplace was a problem because people do it in a different way. People wrote it in a different, the same city had different names, and it took a lot of effort to realize that Istanbul with big letters was the same as with a small letter, and Turkey was Turkey, and things like that. So one thing that we do in practice, and it's something that is highly recommended, it's super important, in particular in molecular biology, is to use a controlled vocabulary. It means that you give a list of possible words that you can use, and you limit yourself to only that word. So if you will say Turkey, and let's say if the country names should be standard, and the way that you write it should be standard. There should not be 3 ways to write the same thing. For example, gene names. Gene name should be standard. One of the problems that you will face later is that the same gene in different organisms have different names. So people get always confused because if you work in Drosophila, you have one name, and then you go to Arabidopsis and they have a different name, and they are the same gene. They are making the same or equivalent protein. So it's a big mess. Same with the, well, one case that people solved this very early was the scientific name of organisms. Some people say yeast, some people say Maya, but at the end you need a way to call it in a way that is very clear to everybody, and you say Saccharomyces cerevisiae. I have a peruche. This is Saccharomyces cerevisiae. Longer story. Basic idea is that you have to use always the same word for the same object. And a way to enforce it, this idea is to use a controlled vocabulary. After we clean it, that is what we did in the last class, we cleaned it doing this program that we did, and we got something like this. By the way, this vector is longer. For this class, I'm showing just part of it for fitting in the slides, but you got the complete data. You can look at it. This is the result after we cleaned it. Okay. So how can we make sure and enforce that everybody using this data will write the things in the same way? Well, the keyword for this is factor. Factors are the tool that we use in R for managing a controlled vocabulary. It's essentially limiting the number of options that you can use. In other context is also called categorical variables. And it's something like in between logic and numbers, because logic values are yes or no, true or false, nothing in between. But if you are speaking about color, you have, well, different way of doing, but typically you will say this is red, green, blue, yellow, something very, very strict, or a city. You have many options, but not millions of options. It's not like a number that you can have infinite decimals. A city, there are, I don't know, 100, maybe around the world you have, I don't know, 10,000 cities in the world, maybe. But it's not more than that. There is a limited. So you have, let's say, 200 countries, and every country you have, I don't know, 100 cities, and that's it. And that's it. You can go exactly to every city with a limited number of options. Sex, you have two values, and you can model like true or false, but it makes more sense to say male, female. It is more logic. So these are values that have a limited number of options. They are not numeric. You're not taking an average of color. What do you mean an average of color? What do you mean average of country of origin? The other word that people use for this is discrete values. Let me give me a very clear example of discrete value. Nucleotide. A nucleotide is A or C or T or G and nothing else. Nothing else. And there is nothing in between. So we want to represent in a way that is efficient and that nobody can make a mistake. And essentially that will help us to do a better analysis later. Okay, it's a tool that helps analysis. So the basic point is that the factors are variables that can take value from only a list of valid levels. We say that you have different possibilities. These possibilities are called levels. For example, and we are going to do it. We take the same birthplace. We start with the character vector and we say make a factor. And this is how you make a factor. I think I will say this later, but in the classic R, in the class that we were teaching last year, factors were kind of automatic. Like every time you get a file, you get factors. But now we are using a tool that gives us a character vector, text. So you have a text column, you wrap it in a factor. So essentially this is a command that says, take this text and make a factor with this. The first thing that you should notice is that first, this is a vector. And you know that it's a vector because you have this bracket here, single bracket showing that what is the index. For example, in position number 13, there is a not available. Second thing is that there are no quotation marks. If you compare with the text version, there is no quotation. These are not text, essentially. Quotation mark always means text. And if you don't have quotation mark, it is not a text. What else? There is this line describing levels. There are 39 levels that start with Azerbaijan, Syria, Turkey, Turkmenistan, blah, blah. So for example, the first is the third level. And you can see, well, we will see later how we can understand this thing. But the point here is that when you work with a factor, you will recognize that it is a vector. You recognize by the bracket here. There's no quotation mark. They look like text, but they are not text. And finally, you have a line describing levels. How many levels and which are the levels? Okay? Any question? So essentially, so far, it looks like a text alike. And yeah, they have something in common with text, but some difference. So to see the difference, let's make a difference. I am going to add a column to the data frame. There are a couple of ways to do this, but I do the classical way. So students, you remember it's a data frame, and I am using this dollar to indicate a column. And this column will be created now. It's not existing. Just look back. We had 10, initially we had 10 columns. And with this command, I am adding a new column. You essentially say the data frame that you have, you give the name of a new column, and you assign a new value. And remember that assigning is always creating something new or replacing something. If it exists, it's replaced. If it is not existing, you create something new. So we take birthplace, we make a factor with that, and we store that factor in a new column called place factor. Okay, so now we have a column, a new column. Okay.
Can I ask something?
Of course.
What are the differences between mutate function and factor?
Very good question. Okay, mutate is kind of the advanced version of this. To be honest, when I wrote the class, I used mutate first. But I found that it was kind of longer to explain. You can do that. You can do also with mutate. So in that case, you take the vector, you say mutate, and you create something like this. And let me show you how I will do that. I don't have the data here, so it will not. It will not work. But you will do something like this. You have students, and then you have to pipe it to mutate, and then you will say something like place factor, and this new column will have the name factor of birthplace. So since students is all the data frame that you are using here, you don't need to write dollar. This is, in my opinion, this is nicer. But I found that the classical way, it was more clear. And the point is that this is creating a new data frame. And you finally, to finish, you have to assign it back to students. So you will have to do something like this. And I hope you. By the way, this is the first day of winter, so I'm using winter colors in my computer now. I am dark mode now. Fine. Let me clear here. That is another way of doing the same. And when I wrote the class, I wrote like that initially. But after I wrote, I found that was not so clear. So I prefer this, let's say, the classical way. So I think it's a good moment to remember that there are more than one way to do things in the computer in general, and in R in particular. In R, we have the point that there is a classical way of doing things, the basic, let's say, low-level thing that I've been working for 20 years, 30 years since R exists. And there are a new set of tools that have been created in the last 5 years or so, maybe 10 years, called the tidiverse. And essentially, they have a different logic, and it's a logic that will work for higher things. So essentially, what I'm saying that choose the one that you feel comfortable. Okay, there is not a universal way to do it. It's like, I don't know. You choose the color of your house the way that you like. There, you choose the car that you like. There are more than one way to solve this. It's not like the correct way. I'm showing you the options. Okay. If I mean, some people are very much worried which is faster. In your case, in my case, we don't care very much because we don't do this so much time. So just what is more logical to you? To me, personally, that I use it a lot, it depends on the day. For sometimes I think one way, sometimes I think the other way. Just, I don't know, you have different tools. When you cook, you can use different pots, different things, depending on how you want to do it. No? So this is kitchen. This is cooking with data. Good question. So, but bottom line, we have several ways to add a new column to the data frame. And I'm doing this just for the sake of comparison, okay? Normally, I will replace birthplace text with birthplace factor, but in this case, I want to keep it so we can compare it. Okay, so we can see what is the difference. Okay, agree? Yes, no? Good. Then, because we will have the same information, but let's see the difference. You will see one difference with the command summary. That you remember when you give a data frame to a summary, it will make you well, depending on the value and depending on the type of data. If you have number, you get minimum, maximum, quartiles. You remember, no? When we spoke about the median and mean and first quartile and third quartile, was probably the last class before the midterm. That is a summary. No, not the last one, the one before. Summary command. Well, the point is here, what I'm doing is using the new style. I take a student and I select 2 columns. Again, there are other ways to do this one. All these things can be done without tidiverse. Just the tidiverse will get you further. You will get to more places. But essentially what you read here is from the student table, select 2 columns and then make a summary of them. In the first case, that it was text and you get a very boring explanation. You say that you have 117 people and these are all characters and the mode is character. Not telling you anything. But when you have a factor, summary is much more smart and counts things. So you have, for example, 35 people in this case, then 7 in Bursa for, how you read this? Tekirdağ, Yalova. 3 people that say Turkey not specifying, and the other are 57, and the number of not available 7. Here we also have not available in the birthplace, but we don't see them. So you have the first winning is that factor works better with summary. Summary will realize that factor are a limited number of options and will count them. Factor are more useful. And in fact, the point is that factor will be super important in the following classes. Then I will ask you a question. Do you know what is factor? What a factor means? The word factor. Do you have any idea what is? Any guess, let's say? No, nobody guess? Okay, so factor is, as far as I understand, a Latin word, because I was in Spanish, and it comes from the Latin facere, which is doing. So a factor is someone doing something in general. So if someone does something, there's a factor on something. Someone has been a factor on the success of the company, or let's say COVID has been a factor in the use of Zoom for teaching. I don't know. So in general, factor is something that has an influence, let's say, has an effect. Not necessarily doing everything, but has an impact. And the use of factor in biology, let's say, it came from the people who invented modern biology, that in other words, statistics, which, you know, statistics was invented by biologists to solve biological problems. Statistics is more biology than mathematics. I mean, it used mathematical tools, but it's not mathematics in the classical sense. Mathematicians don't study statistics. I mean, honestly, I studied mathematics, and when I went to the agronomy department, I was scared because agronomists really know statistics. The people that I know know better statistics are agronomists and psychologists, because their work is statistics. And I got more a theoretical background. So, but the practical thing, these guys are the best. So, and why? Because their business is statistics. They research in plants is statistics. Like what are, and the question that people asked in the agronomy research 100 years ago is like, what are the factors that make plants grow better? a lot of water, little water, the level of sun. So you have some categories of water. Well, you can model eventually water in number of liters, but for them was like dry or wet, and sun was like cloudy or sunny, or thing like very categorical. And they make all this analysis based on and they invented the modern statistic. I mean, statistical inference. So if you have the chance to learn statistics, learn statistics. I always want to teach more, and I never had enough time. Then levels. So factors, my point is that we teach this because it's useful in biology. In fact, I can give you another example. The typical case that we use factor is this. Let's say you grow cells, bacteria, let's say, in different conditions. So you have different cultures, some, let's say, with sugar, some without sugar, let's say. And then you, using PCR or using another technology, you measure gene expression. And the question that you want to ask is, how do they change? How do the gene expression change depending on each factor? So you have, let's say, some cells with sugar, some cells without sugar, some cells with heat, some cells without heat, and you have all combinations. And you combine them in different orders because there are many factors that can. And then the question is not for every particular Petri dish, but you want to ask the question is, what are the factors that affect the gene expression? What are the factors that increase or decrease the gene expression? Or what are the genes that are more affected by this factor? Then when you get factors, when you combine, essentially you have 3 samples with the same factor, and then 3 samples with another factor. Then when you use, and maybe we will do an exercise like this. Okay, let's talk about levels. Levels, as you remember, was the last line, no? So when you print a factor, we'll say that there are some level that are the valid values. You cannot use in this vector, you cannot use something else. These are called levels. And how you know what are the levels? You can ask. There is a simple command called levels. So if you put a vector, a factor vector, level will tell you what are the valid values. In this case, these are the 39 options that we got in our table from Azerbaijan, Syria, Turkey. So what do you notice here? What can you tell me? Tell me something about this value. What is this? This is exercise of looking, exercise of observing reality. What do you see here? You are saying something. Say something. You can say, I am looking at the screen, and the screen has text. There are text that are red, black, and something in the background. Yeah, that is true. Not very useful, but true. Then what else do I say?
Unique valuables.
Okay. They are not repeated. Okay. What else?
I can say all of the birthplace.
Yeah. Well, yeah. Okay. We took from that. What else?
They have alphabetic order.
Alphabetic order. That is a very good one. That is what I wanted to hear. They are sorted alphabetically. That is a decision that someone has to make. Probably because, well, I don't know. You have to choose the levels in some order, and they choose them to be alphabetical. But even there is something before. This is, as I say, this is a character vector. Well, I say it here. You know this is a vector because they are bracket here, and you know this is character because they are quotation marks. So even if the factor is not text, the levels are text. Okay. A factor is a kind of text, but not text because they don't do quotation mark. But the levels are text, okay? By default, the levels are, well, you see all the different vector values sorted alphabetically. And By default, I mean that if you don't say something else, if you let the computer do the things automatically, the computer will do this, will give you all the vector values, all the different, they are not repeated, as you say, they are unique. They are all the birthplace, only once every time, and sorted alphabetically. Agree? They are, when I say, they cover all the cases, and you in the levels, they are not repeated levels. You follow me, no? Yes, no? Like you have questions, many questions. Good, good. Any question? So how can you choose the level? If I say that this is by default, meaning that if you don't say anything, but if you want to say something, how you say? Well, easy. When you create the factor, you can say what are the levels that you want. And I give a still example here because I wanted to make it very, very obvious. Like if the colors, you start with a text vector. This is just a text vector. And for some reason, for an example, these three values are all black. But in your design, in your model, you know that the valid colors are black, blue, and white, let's say. Okay? For some reason, for part of your experiment, you know that you have three conditions. And in particular, in this case, you only observe one. But in theory, it's like, let's say that you are working with rats, and the rat can be male or female. So you have a column called sex, and the sex can be male or female. And for some reason, the one that you choose, they are all male. But it doesn't mean that female is not a valid option. It's just that you don't see it. So in this case, since I don't have enough data, I have to explicitly say what are the options. So, for example, you know that in Turkey there are more than 39 cities. So in the listing that we saw before, the listing of cities, we are missing something. If we are more careful, we can add them intentionally and saying what are the cities that you get in Turkey, and then choose only from them. Tama? Question? Some wise people are taking notes. That is a good idea. You know, I am very much into writing everything. I also taking notes. It's a very good habit to write what you are doing. It helps you remember better, and it also shows that you are paying attention. So try to take notes. You know, there is a risk that you watch the video, and since it is available online, you will feel that you know something, but the truth is you only know when you can write about it, not when you see it. Also,
can I ask?
Of course.
Don't you put any more the edited videos on YouTube channel anymore?
I will. It's just that the problem I have, and I have to solve this. Just before the exam, I updated the software in my computer, and my video editor stopped working. So I have to fix that thing. So I will, but no, everything should be. It's just that I have a technical issue in my computer now.
Okay, thank you.
Yeah, well, good question. At least I will upload the unedited version, okay? But I believe that nobody will watch a 3-hour video. I don't watch 3-hour video. So, okay. See, this is an option that we have. Then we also have the possibility that you want to change the values later. For example, and this is interesting, in the same variable that you had before, I can decide that I will translate the names from English to Turkish. Okay, so I am taking the levels, that the same function that we used to look into the values, but now I am assigning a new vector of text to the old level. So just look here. Here levels are black, blue, white, in that order, black, blue, white. Okay. Here, let's make a test. I can do this in the computer. I copy this and let's do it in R here. Yes. I write this colors, black, 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 level, black, blue, white. And if you say levels of color, black, blue, white. This is a text vector. Then, if I decide to change the, what is this here? If I decide to change the levels, I can do it, but the content doesn't change. So let's do this trick here. Well, you see the result. You will get Sia, Sia, Sia. I hope I wrote correctly. I didn't check it. In other words, I can reassign the names of the values. It doesn't change the values. It's only the name of the values. Okay. So internally, the data is the same. It's just the way that we show it. So colors. And you can even, what are the level colors? You change it. I can do tricks like I can take level colors and assign to upper. You remember that they make uppercase levels colors. I can make all uppercase. So I'm not changing the data. I'm changing the representation of the data. So we will see one more detail in a minute. So what else we have? Level have an order, if you see. And okay, this is also interesting here. When we had another column that was good for a factor, which was the English level. You remember, no? Some people say English is my native language, which I find interesting. I really want to know who is this poet. Someone said that he's writing better than Shakespeare. I really want to see that. And if you don't know English, and my English is not good, but my Turkish is worse. So even my Spanish is not very good, to be honest. So we are in trouble here. But if you see, first question. Here we have 6 or 7 options, no? 1, 2, 3, 4, 5, 6 options. So it makes sense to think about a factor. You don't want people to write different text here. You have only 6 options, okay? So this is a typical case that should be a factor, okay? So it works very well if we do like this English factor, okay? Agree? Yes, no?
Yes.
Now, the problem that we have here is that you start with English is my native language, and but there is an order here. I don't know if you remember, but the order is like the minimum level was English Bilmiorum. Then the second was I can read and understand technical paper. The third is like I can understand movies without subtitles. Then I can speak fluently. English is my native language, and I can write poetry better than Shakespeare. That was the highest level, no? So as you say, this is sorted alphabetically. When we choose the levels, they were sorted alphabetically, and it's not always what we would like to do. So in this case, what I'm going to do, I'm going to reorder them. I could have done this at the beginning, but sometimes you don't know until you see it. So I took the old factor and I make a new factor. I replace the old factor with a new factor. You see, I am updating the column here. I take English factor and I assign to English factor. And the only change is that I do is that I say what are the levels in the order that I want them to be. Okay. So in other words, if you don't specify factors, So if you don't specify levels, they will be automatic with the data that you give and in the alphabetical order. But in many cases, you want to say what is the correct order. You want to say that these are the valid values and this is the order that I want them to be. Okay, so you want to specify levels because you want to say what is the order and when you want to say which are the acceptable values. And now when you print them, they go in an order that makes more sense. Okay. When you make a summary of another thing that we will see next class, the order is important. Okay. And you choose the order choosing the levels. Question? So, when let's say if factors are so good, why we don't use them more? Well, as I say, in the old R, in the classic R, that was the default. And essentially the reason is because this text is not very efficient in terms of memory. For example, the writing 1, 2, 3, you requires 1 byte for the first letter, 1 byte for the second, 1 byte for the third. But the number 1, 2, 3 as a number take only 1 byte. So this should be a space. So we use text when there is not essentially a better option. Text is kind of expensive. Now, the truth is that since computers become more and more cheap, memory is every time more available. So, I mean, 20, 30 years ago, memory was very, very expensive. I mean, I don't know how much memory you have in your computer, but I can tell you my first computer has 1 kilobyte of RAM. My second has 4, and then we upgraded to 8 kilobytes. Then for a lot of time, we want to have 64 kilos, but that was the limit for until the mid 80s. And you had to live with that. So every byte was important. I can tell you stories of tricks that people used for saving memory. But at the end of the day, today memory is kind of cheap. So today people tend to use more text. But you have to use text for things that essentially don't repeat. Remember that every factor will be only one time. So every level will be only one time. So if every individual in your list has a different value, then that is not a factor. For example, if you ask what is the name of the people, everybody will have a different name. If I ask what is your student number, everybody got a different student number. So all this case and sample, when you have got sample from a biological set, you have every Eppendorf marker with some label. These are text. So in general, the thing that identify unique people are text. Even if they look like numbers, the student number is not a number, it's a text. And the basic reason that you know that it's not a number is because you never take the sum of student number, you never take the average of student number. If you don't do arithmetic, then it's not a number. You don't sum names of people, you don't sum student number. In other words, there a kind of intersection between text and factor, and you have to decide when to use one and the other. There are extreme cases, like if you have 1,000 elements in the vector, and you only take 3 values, like red, green, blue, then it's a factor. If most of the values are different, then it's text. If you can know a priori, let's say that maybe that is a point. If before asking the question, you know that the answer is from a limited set, like the English level, then it is a factor. If you don't know what are the options, like what is your name, then it's text. Okay? What else? So factor use less memory, and you will notice this. There is a function, we don't use it a lot, but good to know. There is a function that takes something that is not a number and give you a number. For example, if you use as numeric, you're essentially show me the factor like if it was a number. And you will realize that what's happening internally is that this vector is represented by numbers. Number 3, number 23, number 14, and some NAs. Number 3 is the third level. The third level is 1, 2, 3, Turkey. And effectively, the first element is Turkey. So what happened internally is that factor is stored in two parts. One is a numeric vector with integers, like this, and the other is the list of factors. So internally, everything is a number and can be handled very efficiently like a small number. And then to show to you, they use a translation table that is the levels. And then if you want to change the labels, translating from English to Turkish, for example, or the other way around, you just change the levels. But these numbers don't change. Okay, when I translated from English, when I translated color from English to Turkish, this didn't change. The only thing that changed was the translation, the levels. You see how computers do the trick inside? Fine. Okay, then as we say, in classic R, you have a command called read table, and people doing this course previously only know read table. And by default, if you don't say otherwise, in read table everything is a factor. Every text is a factor. You have numbers, of course, but some are factor. In the tidiverse, we have better options, and maybe you can try to see this one before I show you the summary. Give me 1 minute because we are kind of early for the break. So let's see here. So let's go to, I will look at my history. I will reduce this thing. I will look at my history when I set working directory to the static. Here is where I store the data. Click, and I got from the history the place where I store the data to use. Then I click this button and I see that here we have the student full and student tidy and the COVID data and so on. So now let's read this thing. You go to environment and you have the option here, import dataset. And we are using the second option, reader, here. And maybe I should make it small. Let's see what happens here. If it's too small, I will change it. I browse here. Yeah, good. And we say student tidy TSV open. Okay, here, let's see what's happened. And okay. Okay, let me do something. You cannot see here because the screen is too small. Let me cancel. I am going to reduce the text size so we can see better. I'm doing again. Same thing. Okay, browse. You tell me if you cannot read, okay? So there are a couple of things that you have to be aware here. The first thing, immediately you see that here they are not being separated as we want. And the reason is because the delimiter here is comma. They are trying to read comma. So you say, I want to separate with tab, which was the text that we used here. Now processing again. It's taking so long. Okay, now we have nice columns, okay? There was this option, delimiter. Then also, I strongly recommend that you don't take the default name, use a shorter name. And we are using the name students, okay? First row, our name, and the rest is not affecting us very much. Local here can be to change the language, no, okay, I don't think it's critical here. But now, next point. ID is a character. English level, for example, here it says that it's character. Here you can click and you have options. Okay, there is preview data, and there is an option like guess. Will guess automatically. And the point is, when a computer guess, it can make mistakes. You can say this is character, this is double. Double means real values with decimals. Integer, numeric, which is any of these. Logical, you know, date. This is interesting. Another kind of handling date, time. Date is a day, time is an hour, daytime is both together. And finally, factor. So we can say here, factor. It's asking me the levels. Okay, I don't like this. I didn't like it. Here, for example, we can say this is easier. Here we have male, female. It's marked as factor. Yeah, here we can do the same. It's just that I don't have them at hand. The date, we can say that is date. What is this? Date. It's a date, no? And here you have to choose the format. The format in this case is, okay, let me show it again so we can all agree. The way that I write dates, it's a kind of international standard. You avoid all the problem of American version versus European version, and it has other advantages like it's easy to sort. But essentially the year with 4 digits, then the months, and then the day, year, month, day. That is a better way to write dates. It works much more, you have less trouble in life, believe me. So you can choose here, what was the option? Date. And here I have to say the format. And the format is essentially like this, but in the other order. So we take percentage Y means year, percentage M means month, and percentage D means day. That is, you will see later there's a help that explaining how to handle data here, the dates in R. And we can do something like this. To be honest, it was working well anyway. So let's see what happened. So what we did here, we changed the name, we changed the delimiter, and we specify some column to be date and to be factor, okay? If you say that they are factor, you have to tell what are the levels. And these are, this also can be factor. And here are left and right. That is a kind of an advanced way. So you realize that here, everything that we do is reflected here in the command that we have to do, and we can even copy that if you want to save in your program. So you don't have to do. What I mean is this. The first time when you are exploring your data, you use this import text. But later, if you are going to do this again and again, you just use the same command. We save it. Let's copy here. Import. And let's see what we got here. Let me first, I will create an R Markdown and whatever, okay. Just to remember what we did today. It's always useful to keep memory of what we did. These are the commands that we use. No? So you say R, and the view doesn't work in R Markdown. So next time we don't need to remember. And we can even take a look here and see what are the commands. I don't know if that is important. Column type. That is the point, that there is option called column types, and when you say what are the columns. So answer date is a date, sex is a factor, and these are the levels. Handness is also a factor, and these are the levels. I don't know if you are speaking to me because I nobody is speaking, so I hope that the microphone is working. I mean the headphones. So you may have seen this because when we use the when we don't say what are the column types, when you don't specify them, you will get a message telling you how to guess. I will show you in a minute, but the basic point is that someone has to decide what are each column in the data frame. What are the types? Some option is that you let the computer choose, and the other option is that you choose. In most cases, the computer chooses right, so you don't have to worry very much. But in, I don't know, 5% of cases, you have to tell the computer you did it wrong and do it this way. Okay, if you have to do that, you will eventually have a column like this. You will specify what are the column types. Okay, so let's see what we got. We got, let's say, summary of student. And you see that the date is not taken as a date. I don't know. They are kind of number here. Okay, that's the problem with the summary. But ID is character. English level is character, not factor. Sex is factor. Birthplace is not factor. Handness is factor. Birth date, interesting. This is the median birth date. Yeah, birth dates can be sorted, so median makes sense. What else? Just to show you what was the alternative. If we didn't do this selection, if we just go with the basic command like student to, I'm making a simple version. I would say just real tab separated values. And here you say, what is the name? Student tidy. Okay. I use tab to complete this thing. No, I start writing and tab will give me all the options. Here you get this answer, column specification. You will see this happening and sometime will be in your text. Why I got this one? I got this one essentially because I didn't say what are the columns. If I don't choose the column, the computer will choose the column for me and will give me a report how I make the decision. This is a date, this is a character, and this is a double, never factor. In the other case, we said what are the columns here in the option that you read. Here we say what are the column types. That is how you tell the computer how to work. Fine? Any question? Good. So just to summarize, we have before this class we have seen 3 basic data types in R. Numeric, that is kind of the thing that you get. These ideas correspond directly to the thing that you see in the web, for example, or in any program that you use a menu with the mouse. So you have a numeric is something that you can change like this. No, a numeric is something that you will represent with an input like this, that you have a number of cases. Logic is a checkbox. Yes, no, yes, no. True, false. Text is anything that you can write. Text is, it can be. And finally, we have the fourth data type that are factor, and factor are essentially something that you choose from a limited list. Okay. So in fact, you have seen factors before. When you get any menu, any input that you have a limited set of options, that is internally a factor. Okay. They do not show quotation mark, and they can take only some values. So, well, that are the factors. We are going to use them in the rest of the semester. Probably not after the break, but the next class for sure. Okay. What else? No, well, that is the class. Any question? So after the break, I have another class. Of course, we have another class, and will be a little longer maybe, but it's very disconnected to this one, so I wanted to make the break here. Maybe if you don't have a question now, you may have the question after the break. So it is 12, which is kind of early, but what? I think it's fair that we go for lunch and we go back at 1. Can it be?
Sure.
Because 2 hours will be fine for the. And we will do this. My point is this: if in the meantime you get more questions, think about the questions, and we will we can have another session of questions at the beginning of the next class.